Hello guys, welcome back to calculus class. And this one is about the chapter 5 review and test. And we went over some questions in class together, but I didn't go over everything and I promised you that I was gonna make a video. So you're welcome, Mariani. This one is for you and for everyone. So let's do this one. Let's see if I can go over every single thing, but maybe I will break it down into few videos so that you guys can actually understand this. So here. So this one is the f prime. Well, it's not clear to see, but f prime graph here and from -2 to 5 and says on what interval f is increasing. So increasing is the first derivative of this one. And since it's the first derivative, increasing means any point above this x-axis. So it's gonna be increasing from here to here, -2 to 3, okay? So it's gonna be this one, okay? So easy. Number 2, we did it in class. If you don't understand, A is just let me know. I will go over it again, but that's about it. I don't want to go over it again here. And number 3 here. So at which of the 5 points on this graph figure at the right are dy dx, which is the first derivative, and second derivative are both negative. So this one is actually similar to question number 4 and question number 2 here, but this is something that you will see very often. Watch this. Oh, so by the way, throughout all the video, I will not maybe circle the answer because I want you guys to watch it and figure out by yourself, okay? But I will give you a very clear idea. So first, you have to do this is you have a graph here. Always remember this one. This is number 1, this is number 2, based on this point. This is number 3, and this is number 4. So as you can see, this one is a concave down, this one is a concave up. And as you can see here, this one is what? Positive, because it's going up, but concave down. And this is a negative. This is decreasing, but concave down. This is a decreasing and concave down. This one is a decreasing but concave up, and this one is increasing and concave up. And we want both negative, means decreasing and concave down. So you want something that is number 2. So as you can see, A, that's one is a concave up. This is a concave down. Here to here is a concave down, and as from here it becomes concave up. So this one is what? Increasing but concave down. This one is decreasing and concave down. This one is decreasing, concave up. This one is a 0 and concave up. And this one is increasing, concave up. So you can kind of tell among ABCD which one is the both negative, okay? This, which is B. So this, make sure if you were not in the class, make sure you watch this one. I will just go over this one. The question is asking which one is the second derivative, first derivative, and this one by itself. And you will see this question almost always on the test. So at point A, let's look at point A. So one of this one is going to be 0, one of this one is going to be positive, one of this one is negative. So, and this graph is a normal graph. And in this normal graph, point A is equal to 0. Now, first derivative. First derivative is a slope. And as you can see, on point A, this is a positive slope. So I don't know how steep this is, but I know this is a positive slope. And second derivative, which is a concavity, do you see this one is a concave down? So this one is going to be negative. So this is 0, this is plus, this is negative. So if you want to do it in the order, it's going to be F inverse, F prime. It's going to be in this order because that's the lowest, middle, and that's the highest. If you look at B, that's a little bit different. So first of all, B, that's above x-axis. So F is going to be positive. I don't know what y value you have, but it's going to be a positive number. And that's a 0 slope. So F prime is a 0. And it's still concave down. So F double prime is going to be negative. So that's what we have. And if you order it, lowest to the highest, it's going to be F double prime and F prime and then F. It's going to be in that order. Just like this, you can try C, D, and E. I think E is the only number that you actually have this order, which we cannot really tell, but it does not matter. E is not going to be the answer. So you can kind of tell which one is going to be the answer, okay? Now let's try question number 5. This one is another fun question, I think. Let's see. Actually, I haven't even read it. So here, the graph of f prime, so that's the first derivative, is shown above. The domain of f is open from 0 to d, so here to here. Which of the following must be true? So let's do this. F has a local minimum at x equals 6. So this one is the f like prime. Let's say if it has a local minimum, okay? Now let's look at this. Since it's the first derivative, this one becomes positive to negative. So positive to negative. So is that local minimum at C? No, this one is clearly a local maximum. F has a local maximum at B, right here. That's a zero slope. It's not even max. I mean, it looks like a max. It is a maximum point if it is a normal graph, but this one is the F prime graph, as you can see here. So this one cannot be true. F has a point of inflection at A, so which is a point of inflection A, comma Y, which is f of y at this one, point of inflection. Now, in order to be a inflection point, you should have what is that called? Inflection point means like when it comes to the that's a concavity, right? Second derivative. In order to be an inflection point from the f prime, that has to be either zero slope or undefined slope. And from here, this one cannot be an inflection point because this is just a critical point. Okay, so this cannot be the answer. This is an inflection point and B, this one here, right? Now, do you see this one is a zero slope? Yep, so this is going to be a point of inflection because let's say this is a normal graph, right? If it's a normal graph, something like this, inflection point is a point in the middle like this one, okay, where this negative concavity changes to positive concavity, and which is a second derivative. This is constituted by the first zero slope of the first derivative, which is the slope of the slope. I wonder if you actually understand this or not, but whatever. The graph of f is a concave on open interval C to D. C to D, this one is an open interval, like what? Yeah, is a concave up. If it is a normal graph, yeah, it's a concave up. Only problem that we have is this is the f first derivative of this one. So this is not even concave up. Most likely it's a concave down because this one is a below 0. That's what I assume, but I'm not really sure. So that's about it. So you guys can try these questions by yourself, I believe. I went over this one in class, but wait a second. Do I have more graph this one? Maybe not. Just if you have a let me go over question number 6 for some of you so that you guys can understand this one. So watch this one. Now this function is defined on which interval is graph of x both decreasing and concave up. So concave up, so it's a concave up, and decreasing means this one, right? So you want to find something that looks like this, the one that I highlighted from here, right? So what you have to do is you actually have to put this one into a calculator, but since I don't have a calculator, I will use decimals. I'm sorry to say it, you cannot use decimals only because they will not let you do it. So you actually have to use TI Nspire. That's gonna be a little bit tricky, but I hope you get used to this. But here, let me use decimals here. So look at this. So which interval looks like this one on this one? So to me, it's from here to here, right? Which of the following is from both decrease concave up? Yeah, so it's gonna be here to here. So it's from -1 to 2. So it's gonna be C. So I think that's about it for this one. If you have any other question, just let me know. Question number 7, I think it's self-explanatory by just looking at this one. Yeah, that's about it. All right, see you guys from the next. So to be continued. Bye, guys.